Welcome to the shocking Coulombs law video, third video of the chapter. Hopefully I will present an electrifying video that will help you learn about Coulombs law. Coulombs law is a law that helps us calculate the electrostatic force between two charges. If I draw two charges here, let's say a positive and a negative, these two objects are going to attract one another with a force. The positive will feel an attractive force and the negative will feel the same attractive force. And Coulomb's law tells us that the electrostatic force is impacted by the two charges, Q1 and Q2. So it depends upon the product of the two charges, Q1 times Q2. And it also depends upon the distance between the two objects. But it's proportional to the product of the two charges and inversely proportional to the distance squared. So the equation for Coulomb's law, which is the equation that we're going to be using, is F equals. There's a constant that goes out in the front. It's a small k, the electrical constant. F equals k times Q1 times Q2 over d squared. And that is the electrostatic force equation, or Coulomb's law equation. And the k is an electrical constant, and it equals 9 times 10 to the 9th newtons meters squared over Coulomb squared. Now, if that equation looks familiar, that's because the universal law of gravitation equation is G m1 m2 over d squared. So when we're talking about gravity, the important property of an object is mass, and the distance squared is pretty important between them. As the distance grows, the force of gravity shrinks. And if you look at the electrical equivalent of that, the thing that's important for the electrical force is the amount of charge, but the distance squared is important. Now, if you look at the K constant, this number tells you that the electrical force is very strong, because if you look at the gravitational constant, if you remember it, it's 6.67 times 10 to the negative 11. So just by the constants alone, you can see that gravity is very weak and the electric force is very strong. What I'd like to do now is an example using the Coulomb's law equation. So if you read along the example with me, it says 2 point charges, one of negative 1 microcoulomb and the other of 2 microcoulombs, are separated by 0.3 meters. What is the electrostatic force between the two? And is it attractive or repulsive? Well, first thing, we can actually answer the second part of that question, because these are opposites, so they are attracting one another. And I'm going to write the equation, K, Q1, Q2 over d squared. And I'm just going to plug in the numbers. It's already solved. So 9 times 10 to the 9 times... Now, I do have to convert negative 1 microcoulomb to coulomb. So that's 1 times 10 to the negative 6. And I should point out, if you notice, I left out the negative. We are going to leave out the negatives. We're leaving out the negatives because all the negatives really tell us is if the force is attractive or repulsive. And if we just look at the charges, we can figure that out on our own. So we just want to find the absolute value of the electrostatic force between two charges, and we'll worry about direction at another time. So 1 times 10 to the negative 6 times 2 times 10 to the negative 6 over the distance squared, which is 0.3 squared. And it turns out that the electrostatic force between these two, if you do the calculation, you can pause it if you want to do the calculation, but the number is 0.2 newtons, and that's attractive because of the beginning part of the problem. And there you have an example of how to use Coulomb's law.